Welcome, seventh graders, to lesson 5.2. Today we will be representing one-step equations from phrases and from real-world problems. You will need your 5.2 notes, a pencil or a pen, and a calculator. And if you have all of these items, you are ready for today's lesson. If not, pause the video and go get everything that you need. All right, let's begin. Please find this on the left side of your notes. We're going to first begin by reviewing which operation do each of these words represent. Let's first look at the word sum. What operation in math does that word represent? Yeah, addition. Write the plus sign. What about the word difference? What operation does that word represent? Absolutely, subtraction. What about product? When you see the word product, what operation in math does that represent? Yes, multiplication. And that leaves quotient. What operations left? Division. What about when you see the word is? Like 4 plus 5 is 9. What mathematical symbol represents the word is? Yep, you've got it, the equal sign. Okay, now I think we're ready to begin. We're going to begin by taking a look at mathematical sentences or phrases, and we're going to change them into an equation that can be solved for our unknown variable. Let's get started. Okay, in example number 1, it says the quotient of a number and 3 is 152. Let's take a look at some of our key words that we see in this sentence. We see the words quotient of a number and 3. We know that quotient means to divide. So we're going to be dividing a number and 3. Now, with that fancy word quotient, when you see the word quotient, you're going to be looking for the word and. The and is a connecting word. That is where the division symbol will be going. So when it says the quotient of a number and 3, it's literally a number divided by 3 in that order. But we're going to use the fraction bar for divide. So we're going to write n divided by 3, and then next I see the word is, and is represents the equal sign in math. So I'm going to be putting an equal sign right where I see the word is. So equals comes next, and then the number 152. So what I did was I changed this phrase or sentence, I suppose, and I changed it into a mathematical equation. Quotient of a number and 3, right here, n divided by 3 is 152. Now we are ready to solve. Okay, so I'm going to put a line down the equal sign. And remember, my goal is to get the variable by itself. It says n divided by 3. So we want to undo the divide by 3 to get the n alone. So the inverse of divide by 3 is to multiply by 3. I want to do the same thing to the other side. So remember, this is 3 over 1. The 3's will cancel because they both have a common factor of 3. They divide out. And we have n left by itself, and that was our goal. Then over here on the other side, we're going to use our calculator, and we're going to take 152 times 3. I'm going to triple the 152, and I get 456 for the value of n. All right, so my solution over here is going to be 456. That's my solution. So the quotient of 456 and 3 is 152. I figured out that missing number. Let's take a look at the next problem, number 2. Okay, we're going to read it here. It says the product of a number and -9 is -54. So we're going to take these words and we're going to replace them with mathematical symbols. That's going to give us an equation which we can solve. So let's look at this one. I see here it says the product of a number and -9. Okay, product, well, that means multiplication. So we are going to be multiplying a number and -9. Remember, with that fancy word product, look for the connecting word and. That's where we're going to put that multiplication. Now, with multiplication, we want to be sure that we're writing this properly because we're in pre-algebra. So if I just write the product of a number and -9 is n times -9, we know that that's not the correct way in algebra to write multiplication. If we want to take n times -9, we want to write it as -9 times n with the number and the letter connected together, right? And the number always comes first. Okay, so we're going to write negative, the product of a number and -9, just like this. And then do you see how it says is? Is means equals. So I'm going to write the equal sign. And then we've got the number -54. Okay, so let's just check it. The product of a number and -9, which is right here, product means multiply, is -54. So our goal is to figure out what is that number. The product of what number and -9 is -54? I bet you know what that is in your head right now. What times -9 is -54? All right, let's figure it out. So I'm going to put a box around the n, reminding myself I want to get the n by itself. Do you see how it's stuck to -9 with the invisible multiply operation? So I'm going to undo that with division. I'm going to divide not just by 9, but bring down the negative, -9. Okay, I have to do the same thing to the other side. Now look what happens here. -9 divided by -9 is positive 1n, and I have n all by itself. Over here on this side, I have a -54 divided by a -9. Signs agree. That's positive, +6. And again, you can just use your calculator too. If you need to go ahead and take 54 divided by 9, that's always okay to do too. Okay, so the product of the number we're looking for is 6. The product of 6 and -9 is -54. So my solution right here is 6. So there we have number 1 and 2. We were using the word quotient and product, so these are really good to know right over there on the left-hand side. Let's take a look here at number 3 and 4. Okay, let's focus on 3. 10 less than a number is -32.25. Okay, so I see we've got 10 less than a number. I'm going to change that into symbols. And then the word is, we know that the word is, I'm going to pull this back up here for us. Remember the word is, that's the equal sign, right? So is equals, and then we have the number -32.25. Okay, so what we really need to change here is 10 less than a number. But you know, over on my list here, I don't have the words less than. So we have to think what operation symbol it does less than represent, and that's subtraction. But be careful, this is 10 less than a number. Think about if we were trying to find 10 less than your age. Wouldn't you take your age and then -10 after it? The words less than are turnaround words. So we're not going to write 10 minus n. It would actually be that number -10. The less than is a turnaround word. Well, think about it. If it's 10 less than a number, what if I said, what's 10 less than your age? Your age would be the number, and you'd -10. That's how you would find 10 less than your age. So this 10 goes off the back, okay, at the end. Then we have is, and then -32.25. There we go. So 10 less than a number and -10. All right, let's figure out what the answer to this is. What is the solution? Here's my equation. Let's solve. So I'm going to put a line down the equal sign, box around my n. My goal is to get the n by itself. So I want to undo the -10, which would be adding 10 to both sides. Bring down the n. Now over here on this side, I've got decimals, and if you can always use a calculator for this. I've got -32.25, and I want to add 10. So I'm typing it right into the calculator, -22.25. 22.25. That was quite the tongue twister there. And there is my solution for n. So solution over here, -22.25. I wrote that correctly. There we go. There's our solution. So careful with those turnaround words. A lot of times when you see the word than, that kind of signals taken from, less than, those are turnaround words. All right, number 4, focusing on number 4. Okay, let's see what this one has for us. I've got 1/4 of a number is 31. I know is means equals, and then I've got the number 31. But what about this 1/4 of a number? I've got to change that into symbols. Of. That's not on our word list here, but we know what of means. Of means to multiply. So right here where I see the word product, let's add the word of. Right to the left of your notes. Of also means to multiply. So when I see 1/4 of a number, I have 1/4 times a number. Now, I don't really need the dot there. I'm just putting that there just to accentuate the fact that it's multiplication. But yeah, 1/4 n. And then I have is 31. Of means to multiply. All right, let's do some solving here. We got our equation, a fourth of n. And I'm going to put my line down the equal sign. And our goal is to get the n by itself. So look at what's been done to it. It's being multiplied by 1/4. So we'd want to do the inverse, right? Divide by 1/4. But hold on, stop, wait a minute. There's a fraction attached to the variable. What's a quicker way to undo the 1/4 than division? Do you remember? Yes, yes. Multiply by the reciprocal. So if I multiply by the reciprocal, that's 4/1. I do the same thing over here. Multiply by 4 or 4/1. Now the 4's cancel because they're both divisible by 4, and I get 1n. Hello, that's what we wanted, 1n. But over here I got 31 times 4. That's just 4, right? So I can use my calculator, unless I know what 31 times 4 is in my brain. That works too, 124. See how much quicker that is than dividing, right? When we see a fraction attached to the variable, we multiply by the reciprocal, and the solution is 124. Awesome. Okay, so this is where we were looking at phrases, sentences. We were changing them into mathematical equations and solving. That was examples 1 through 4. All right, we are ready for changing our real life problems, right? If we can look at real life problems and see if we can write an equation that tells the story. Okay, here's number 5. We're flying. All right. That sounds good, right? Flying somewhere on a nice vacation. You're flying at an altitude of X feet. So a lot of times a picture is really helpful to see what's going on here. So here's our airplane flying up at X feet. This is what we got here, X feet. I'm just going to put X right here. We don't know how many feet high this is. We're going to call it X. You descend 6,891 feet. What does it mean to descend? Yeah, go down. We drop. See my picture here? See us dropping? We're going to descend. We're going to minus. Ascend means to go up. Descend means to come down. Kind of like the word decrease. We go down. Okay, so we're going to decrease. We're going to descend 6,891 feet to an altitude that is now equal to 18,479 feet. So write and solve a subtraction equation to find your original altitude x. So we want an equation that's going to tell us a story of what's happening here. We want a subtraction equation. It makes sense because descending means to drop down. So let's start from the very beginning. Okay, on the left-hand side here, the very beginning. Do we know our original altitude before any change happened? No, we're going to call it x. I'm going to put a box around it. Then what happens? We're flying at X altitude. We're flying, and then what do? We decrease, we fall, we drop. We drop 6,891 feet. And now our new altitude is equal to 18,479 feet. I'm going to run out of room here. This equation tells us the story of what's happening. We start at a high altitude, we descend, and then now we're equal to this altitude. Where were we before we descended? I'm going to draw a line down the equal sign. All right, we want to get the x by itself. What's been done to it? Minus. So we're going to do the opposite. We're going to add. Okay, negative 6,891 and a positive 6,891. That cancels out, and I have x. I can drop the x down all by itself. Over here, we're going to take our we're going to take our altitude that we're at right now, 18,479 feet, and we're going to add back on the amount that we descended. So it's like we're going to go back up. And now we have 25,370 feet. Oh my goodness, that's pretty high, right? That's where we were at. So this X is representing 25,370 feet. Does that make sense? And then we drop down here, 6,000, and we're down here at 18. So we just added the decrease back on and brought us back up. But we represented it with a subtraction equation, right? So the original altitude we're going to put here in our sentence, 25,370 feet. All right, let's try number 6. The cost of 3 t-shirts at $D is $59.85. So we bought 3 t-shirts at D dollars. Write and solve an equation to find the cost D. When it says 3 t-shirts at D dollars, it's another way of saying that we bought 3 t-shirts and they were each D dollars. But you'll sometimes see the word at $3. It means at D dollars each. Okay? So this t-shirt costs D dollars, this t-shirt costs D dollars, and this t-shirt costs D dollars. And those are little price tags that are kind of connected to the t-shirt. Okay, little price tags. They're each D dollars. So the total here is $59.85. Write and solve an equation to find the cost, D, the cost of each t-shirt. So I'm going to start by putting my total. We know total generally goes here after the equal sign, $59.85. Now, could I do this by going D plus D plus D? D plus D plus D equals $59.85? Yeah, absolutely. You could go D plus D plus D. What's a quicker way than writing D plus D plus D? Ah, multiplication. Yeah, each means multiplication. So I could take 3 t-shirts times D dollars each, right? Well, think about it. D plus D plus D. What would that be? Ah, 3D, right? So 3 times however much they each cost, because I'm buying 3 t-shirts, equals our total. All right, let's solve this. So it makes sense for a multiplication equation. All right, so this is multiplied. We want to get D by itself, so look what's been done to the variable. It's times 3, so we undo it by dividing. We're going to divide. Well, it makes sense here that we're going to take our total amount of money and divide it by the 3 t-shirts. Calculator is going to be really helpful for this. So 59.85 divided by 3, $19.95 a piece. That sounds about right. Cost of a t-shirt. So they each cost $19.95. $19.95, $19.95, $19.95 would add up to be $59. So $19.95 each. And we did it. Multiplication equation this time. All right, last one, number 7. Boy, this really reminds me of summer with the lemonade stands. Oh my goodness. 5 friends are going to have a lemonade and cookie stand on a hot summer day. At the end of the afternoon, they earned X dollars. So they counted up all their money and they got X dollars. The friends shared the money equally among all 5 of them. Each friend received $6.35. So the question's asking us, how much total money X did they earn? What amount of money X did they earn before they divided it by 5 people to each get this much money? Okay, so what was their total before they divided it? All right, we can do this. Let's tell a story of what's happening. We have 5 friends that earned a total of X dollars, and they're going to split it evenly. They're going to share it equally among the 5 of them. Just the word share the money equally tells us that this is going to be division, right? They're dividing it so everybody has the same amount of money. Each friend receives this much money. So after our equal sign, they're each going to get $6.35. Okay, let's go to the beginning here. What happened? Well, they took all of the money X and they divided it by 5 people. So let's show that. All the money X and they divided that by 5 people. So we got to figure out how much money this was. What's this amount of money, this total money where they divided it by 5 and they each get this much money? All right, so we've got division. Okay, so we're going to undo what's been done to the X, divide by 5. Let's undo that with the inverse operation of multiply by 5. We got to do the same thing to both sides. Remember, this is 5 over 1, so the 5s will cancel, and I get X is equal to. Now let's take that $6.35 that they each get, and we're going to multiply it by 5 groups of that. Oh, $31.75. That's what they started with. So when they were selling lemonade and cookies, they earned a total of $31.75. So that's the X, $31.75. Then what they did was they divided that by 5. You can check your answer, divide that by 5 kids and see that they all get the same amount of money, $6.35. So we had a division equation, we had a multiplication, and we had a subtraction equation. Let's do a summary together. Let's take a look and summarize. Okay. When we are taking phrases or sentences and changing them into an equation to be solved, or even when we see a word problem, it's important to know what these operation words mean. So let's review. Sum. What does it mean when we see sum? Yep. How about difference? What does that word mean? Absolutely. What about product? Yep. And quotient? That's division. Now, when I see the word is, I want to change it into what symbol? Equals. Perfect. It's important we know these because when we're changing phrases into an equation, we want to change the word into a mathematical symbol. Thank you so much for joining me today. It's been fun.